Hi, and welcome to another video for Math 098, Intermediate Algebra. Today we're going to talk about section 9.5, which is rationalizing the denominator. In this video, we'll discuss our first objective, which would be denominators with one term, and in our next video, we'll discuss denominators with two terms. So let's go ahead and look at our first example. For problem number 1, we're asked to do the division for the square root of 3 divided by the square root of 2. Now the problem is we can't have square roots in the denominator, and we don't know what the square root of 2 equals. Well, it doesn't work out perfectly. So what we have to think about doing is, what can we multiply by the bottom so that the square root works out perfectly? Well, what about the square root of 2? How about we multiply by the square root of 2? Well, in order to make this legal, we would have to multiply by the square root of 2 on the bottom, as well as the square root of 2 on the top, because really what we're multiplying by is a fancy version of the number 1. So if we multiply the top together, we end up with the square root of 3 times the square root of 2, which is the square root of 6. And in the denominator, we have the square root of 2 times the square root of 2, which becomes the square root of 4. Now the benefit here is I know what the square root of 4 equals. The square root of 4 is equal to 2. This is our final answer. The good news about this final answer is I no longer have a square root in the denominator, and that's the goal. Okay, so let's go ahead and try a more difficult problem. How about 5 divided by the square root of 18? So you might want to multiply by the square root of 18, which is the same technique we used over here. Multiply by the similar square root to get a square root that works out perfectly. However, that's a little bit larger than maybe what we need to go with. So let's think about square roots that work out perfectly. Well, the square root before 18 that works perfectly would be the square root of 16. What is the next square root that works out perfectly? Well, that would be the square root of 25. I can't turn 18 into 25 by multiplying by a number, but let's continue this list and see if we can find one that does work out perfectly. The next square root that works perfectly would be the square root of 36. And notice, if I take 18 and multiply by 2, I could turn that into 36. Okay, so that is our goal. Let's turn the square root of 18 into the square root of 36. In order to do that, it just so happens, coincidentally, that I'm going to multiply by another square root of 2 in the bottom. Well, again, remember, if I multiply by the square root of 2 at bottom, I have to multiply by the square root of 2 on the top. Just another fancy version of the number 1. So now let's multiply the tops together. Remember, when multiplying radicals, what's inside stays inside, and what's outside stays outside. So I can't multiply 5 times 2. 5 has to stay outside, and 2 has to stay inside. Let's go ahead and multiply the denominators together. Square root of 18 times the square root of 2 is the square root of 36. Now this is where we would like to be, because in this case, I know the square root of 36, that's equal to 6. So our final answer will be 5 square root of 2 over the square root of 36, which becomes 6. Again, this is the most simplified version of our original problem because this problem has a square root in the denominator, and that's not simplified. This problem now doesn't have a square root in the denominator, so it's simplified. Let's try one more example. What about the square root of 5y in the denominator? Again, we don't know the square root of 5, and we don't know the square root of y. A lot of times we are allowed to simply multiply by the same exact square root. That would be the square root squared. Well, let's go ahead and see what happens in this example. I'm going to multiply by the square root of 5y. Again, what I do to the bottom, I also have to do to the top, because this is just a fancy version of the number 1. So let's make sure we're multiplying these values together in the top correctly. Again, what's outside the radical stays outside, and what's inside the radical stays inside. So I have 10 times the square root of 5y in the bottom, or I'm sorry, in the top. And in the bottom, I have 5 times 5, which gives me 25, and y times y, which gives me y squared. Remember, those were under the radical, so they stay under the radical. Again, the good news is, in the denominator, I now have a square root that works out perfectly. So let's go ahead and simplify that. The square root of 25 is equal to 5 and the square root of y squared is equal to y. Now, if you're thinking about trying to simplify this a little bit further, that's good news. The bad news is make sure that we simplify correctly. Is it pretty tempting to cancel this 5y in the top with that 5y in the bottom? Probably tempting. Hopefully you recognize that that's not okay though, because what's under the radical has to stay under the radical, and what's outside the radical has to stay outside the radical. So what we're allowed to cancel in this case is the 5 in the denominator with part of that 10 in the numerator. If I reduce by 5 in the top and in the bottom, our final answer will leave a 2 square root of 5y and simply a y in the denominator. So here are some examples of how to rationalize the denominator with one term in the denominator. And in the future videos, we'll talk about more complicated examples that have two terms in their denominator. Good luck.